Okay, example 4, given the functions f of x is equal to x minus 3 and g of x is equal to negative x plus 1, evaluate. Okay, so we're told we want to add these functions in this first example. So we're going to go x minus 3 plus negative x plus 1. Now we could write this negative 4 saying we could substitute in negative 4 for our x, and maybe that's the best thing to do at this point. So we'll find that f plus g of negative 4 is equal to negative 4 minus 3, and that's going to be minus negative 4, because a plus and a negative cancel out, making this negative, plus 1. And you're going to find out that that's all equal to negative 2. Okay, that's not so bad. Here we have f minus g. Okay, so f minus g of 6, so we're substituting x for 6 then. It's your choice. You could simplify this more before actually substituting it in. I'm not sure in this case there's really any value to that. These aren't that complicated. So we have x minus 3 for g of x, so it's going to become 6 minus 3, and then, sorry, that's f of x. And then for g of x, we have minus, now there does need to be brackets there, and then negative x, which is now 6, plus 1. And when we simplify that, we get 8. Great, on to some word problems then. So Reach for the Top is an academic challenge program offered to students across Canada. Suppose the cost of t-shirts for the program includes $125 in fixed costs and $7.50 per t-shirt. The shirts are sold for $12 each. So write an equation to represent the total cost, C, as a function of the number of t-shirts, N, produced. Now this looks very similar to a lot of other word problems you've probably done in the past. We're just going to approach it a little bit differently, using our function notation and the ability to add and subtract them. So we're looking for our total cost, which is C, and that's C of N, because that's our number of t-shirts we sold. We're told there's a fixed cost of $125. Plus it costs $7.50 per shirt, so $7.50 N. Okay, that's it for A. So B, write an equation to represent the revenue as a function of the number of t-shirts. Okay, well that one's a little bit easier actually. So now it's going to be R based on the number of shirts we have, so R of N. And we're told that we make $12 each, or at least we sell them for $12 each. And that's it. Okay, C, graph the total cost and the revenue functions on the same set of axes. What does the point of intersection represent? So I'm going to graph this in Desmos. So we've got our two graphs, and we're looking for this intersection point, and we find that it's 27.778. Well, what does that mean as far as our graph or our question? Well, that's the breakpoint even, breakpoint part. So that means we need to sell 27.8 shirts to break even. Now you can't sell part of a shirt, so it's actually going to be 28 shirts then before we start making any money. So speaking of money then, so D, profit P is the difference between the revenue and the cost. Write a function representing P in terms of N. Now this is where we're going to start using our function notation, because our profit, based on the number of shirts we have, is actually our revenue, so R of N, minus our costs, in this case C of N. Now we can do that substitution, so R of N is 12N, and C of N is 125 plus 7.5 N. Now that does have to be in brackets, and then that will simplify to 4.5 N minus 125. And that's what our P of N, or our profit, is equal to. So then we have E, identify the domain of the total cost, revenue, and profit functions in the context of this problem. Well, our domain is based off of our X, which in this case is N, and N is our number of shirts. Well, N must be such that N is greater than or equal to 0. We can't sell less than 0 shirts. Now, N can't be a real number because you can't sell part of a shirt. So therefore it has to be a whole number as well. All right, example 6. Math Kangaroo is an international mathematics competition that is held in over 40 countries, including Canada. Suppose the cost of preparing booklets for the Canadian version of the contest includes $625 in fixed costs and $350 per booklet. The booklets are sold $30 each. Write an equation to represent. So we have A, the total cost C as a function of the number of booklets sold N. So very similar to the last one. So here we're going to have C of N. And we're told that there's $625 just as a fixed cost plus $350 per booklet. So $350N. B, the revenue as a function of the number N of booklets sold. So our R of N. And we're told that we have $30 per booklet, so 30N. Okay, then our profit, C, so I'll do that down here. Well, our profit is going to be equal to our revenue minus our costs. So in this case, our revenue is 30N, and our cost is 625 plus 3.5N. Again, very important that that is in brackets. So then you get 26.5N minus 625. Finally, graph the total cost, revenue, and profit functions on the same set of axes. How many booklets must be sold to make a profit? Now this time I'm going to graph it a little differently. I'm actually going to just graph our profit. And our x-intercept is the point that we care. This is where we start making money. So the height is the amount of money made. So we find it 23.496. So it's going to be 24 shirts, or sorry, books in this case, before we actually start making money. So for D, it's going to be 25 books or booklets. Okay, E, identify the domain of the total cost, revenue, and profit. Again, the domain, you can't have less than 0 for these booklets. So we're going to have something where it's N such that N must be greater than or equal to 0, where N is a whole number.